everyone. My name is Rakshat Sharma and today we are going to learn a new chapter under the category of modern physics that is called as electrons and photons. To start with this chapter, we need to understand the dual nature of light that we are going to study in this module. Now students, we already know light has two kinds of nature, that is the wave nature and the particle nature, and in this module we are going to understand few basics about the dual nature of light. The very first nature of light that we are going to study is called as the wave nature. Now whenever I say the word wave, what does it say to you? Can I say whenever I hear the word wave, it gives me some examples like this: ripples formed on the water. Whenever I drop something into a still lake, there are some disturbances which are produced on the water. Can I say those behave like waves? So this is one example of waves that come to me. There is another example of waves that is very common, that is the sea waves, which tell me about the wave nature. But students, in this case, the light behaves like wave. That means light exists in the forms of wave. And how do I define wave? Because I need to study the wave nature, I also need to know the basic definition of wave. Wave is defined as mode of transfer of energy. And in this mode of transfer of energy, the light waves exist in the form of alternate crest and trough. And to study wave nature in detail, we had already few characteristic properties which were explained only by the wave nature. And those few characteristics had the number one characteristic, that is reflection. Now this property was only explained by wave nature in the start. What it said that it is a phenomenon in which an incident wave is bounced back from the surface of an opaque medium. Now you can see the reflecting surface over here. There is an incident ray which is coming. This is my normal, and also I have one reflecting ray. So you can see it is a phenomenon in which incident wave is bounced back from the surface of an opaque medium. The angle which is made by the incident ray is called as angle of incidence, and the one which is made by reflected ray is called as angle of reflection. For the case of reflection, angle of incidence will always equal angle of reflection. And the beautiful example you can see over here is the moon's reflection that we can see in the water. Moving ahead, there were a few other characteristic properties that were explained by the wave nature of light. That was refraction of light. Now how do I define refraction? It is bending of light ray. When the light ray moves from one medium to another medium is called as refraction of light. You can see this refracting surface. I again have my incident ray which is coming in. Now this incident ray is changing its path, or it is bending. That bending causes a phenomenon which is called as refraction of light. You can see the angle made by the incident ray is called as angle of incidence, and the refracted ray is making certain angle which is called as angle of refraction. Now we know angle of incidence is not equal to angle of refraction, and the common example that we can see is when I put some object into the water. The object will appear as if it has bent, but it is not the object which has bent. It is the light ray coming from that object is bending, and that is why that pencil appears to be broken, but it is actually not. Moving ahead, there were few other characteristic properties that were explained by wave nature, and one of them is called as interference of light. What happens in interference is that it is a phenomenon in which there is a superposition of two light waves which is happening. Two light waves are superimposing, and there is a resultant disturbance which is produced. Now this resultant disturbance causes redistribution of light intensity or energy. Now many of the students do not know what does actually superposition mean. That is why to study superposition in detail, we'll be seeing what actually superposition means. To understand superposition, let me consider a wave. Now any wave will always have a particle which will perform oscillatory motion. I can see in this case there is a particle performing oscillatory motion with an amplitude A1. You can also have another wave again arriving at the same point having its amplitude A2. Now when both the waves arrive at the same point simultaneously, they produce a resultant disturbance. You can see one wave is reaching, you can see another wave also reaching. Both are reaching together and they are producing a resultant disturbance. Now this resultant, students, you can see is a larger crest and a larger trough, which is a vector sum of the individual waves. So this is one of the property that was explained by the wave nature. There was also one more characteristic property called as diffraction of light. In diffraction of light, it is actually a bending of light ray near the edges or the corners of an obstacle spreading into the region of geometrical shadow. So you can see this light source which is meeting the obstacle and the light ray is getting spread, which is causing the geometrical shadow. We must know that this geometrical shadow has illumination in the edges that shows that the light ray actually bends. And if we have to see in detail, here we can see that the shadow of the obstacle is not sharp and hence there is a phenomenon called as diffraction. We move ahead to study the second nature of light, that is the particle nature. In this nature, light was said to behave like small discrete set of packets of energies, and this was given by scientist Max Planck, who told that this discrete set or packets of energy was also called as quanta or photons. Now these photons, as you can see in this diagram, are shown like this. So you can see a source of light and these packets of energies are called as photons. So students, in this module, we studied about the wave nature as well as particle nature of light. Thank you.